let's add to our discussion of logs, and we're going to talk about properties of logs. Properties of logs. Like I said, this kind of is a continuation of yesterday, so certainly put it nearby. Now, I get good news about properties of logs. They actually come from properties of exponents. The reason that's good news is because we've talked about properties of exponents. But I think a little birdie said that logs are exponents. So it would be fitting that the properties of logs would come from the properties of exponents. Let me see if I can help you understand that a little bit today. Here's what we commonly call the product property. Obviously, jot it down, but I like to help you understand what it's really saying. So we have the log base b of mn. That actually equals the log of m plus the log of n. Okay, this is a product. You're multiplying m and n. We are able to write it as a sum. Now, believe it or not, that actually comes from a real simple exponent property. I'm confident that you guys understand that when you're multiplying, you add them. When you're multiplying, you add them. That's exactly what this is saying. When multiplying, you add them, because logs are exponents. So really, in a direct connection, this is the same as the atom property. Okay, see if you can catch on with the next property. It's called the quotient property. But honestly, what it's really showing is that you subtract them. It's called the quotient property. We have a fraction. We have a fraction, as the little rhyme goes, when you have a fraction, subtraction. So again, we have a pretty basic property back from a week or so ago, honestly back from Algebra 1. I know you guys know that you subtract these exponents. You always subtract when you have a fraction. That's exactly what this is saying, because when I have a fraction, I'll do subtraction. Notice what I'm subtracting. I'm subtracting logs. When you subtract logs, it's like subtracting exponents, just like subtracting 5 and 2. I know it's kind of weird. It's like, what? But a log is an exponent, so it follows the properties the same. Now, you might wonder why I'm saying this, because it sounds kind of obvious, but it's really how people understand both of these properties. Whatever's in the denominator is always going to be the negative. Why am I saying that? Well, if you had like 3 things in the denominator, guess what? You would have 3 negative logs. So whatever's in the denominator is always the subtraction. Whatever's in the numerator is always the addition. Technically, this one here is the one that's positive. You're going to see problems where we have more than just 2 logs. Maybe I have like 6 logs. Subtraction goes in the denominator, addition goes in the numerator. Power property. Power property. All these properties are important, but you actually find yourself using this one the most, which is good news because it's actually quite simple. P is a power. P is a power. I want you to see what's happening to it. Like a little germ, it's sliding out front. P is falling down. It's coming out front. It's becoming a multiplier. Now, this property actually comes from, once again, a basic exponent property. It's a property where you would say you have like a power to a power. I think everybody realizes that 5 and 2 are powers. So what do you do when you have like a power? You have a superpower. Actually, you just multiply. You just multiply. Look carefully. This is kind of neat. This is like a power. Say what? Well, P is a power, but remember, logs are powers. So it's like I have 2 powers here. What do? You multiply them. Okay, now I'm not going to make you write an essay about how those properties go to this, but it does sometimes help to see that they're the same. What you really want to be able to do is apply the properties. Now, when we apply them, we're going to do 2 things. One of them is called expanding, and then the other one we'll do in a moment. But right now, this is like a technical process that you do with logs. It's called expanding. And when you expand a log, you kind of do what it says. You take it and you pull it apart. And as you'll learn, you pull it apart to like its lowest terms. But let's do one thing at a time. This is the log of 4x squared over 9. By the way, I did not write the base. If I did, or if I didn't, it wouldn't matter. I'm still going to use the property. But if you're wondering, the base would be a base 10. I just didn't write it to kind of save a little writing. Okay, the base does not really matter for these properties. It just needs to be the same. Okay, now lots of things going on here. Honestly, there's a fraction. Fraction means subtraction. There's also, I like to call them like 3 items up here. Okay, those items you're going to learn get all split apart to be like 3 logs. It helps students to see that it helps when students see that there's 3 things up here, because right away you can get yourself ready with 3 logs. What do you mean 3 logs? Well, it's going to be the log of 4, it's going to be the log of x squared, and it's going to be the log of 9. So that's the first step in expanding. Each item becomes a log, which is really what the first 2 properties say up here. Okay, we kind of took the first 2 properties and sort of used both of them. Now, if you're like, is this stuff like added or subtracted? Well, you're exactly right. Remember, whatever's in the denominator is subtracted. Whatever's in the numerator is added. Well, this is a good example of 2 items that are added or positive. Now, the plus sign I put right here is not necessary, but just to drive the idea home. Okay, this is a job well done, but it's not complete. It's not fully simplified, or I should say in lowest terms. Okay, for one thing, when a power is here, it's able to slide out front. That's a big one. Okay, just so you get the idea, we're going to write this as 2 log x. But, and this is kind of the next level of thinking, I need to show you this. It's actually true that 4 and 9 can undergo the same transformation. What am I talking about? Well, you have to realize that the number 4 is the same as 2 squared. You either see that just in your head or you rewrite it. You say, why did you write that as 2 squared? Well, because now that it has an exponent, it can come out front. And what's really happening here is I have lower terms. Lower terms just means the numbers are smaller. I'm kind of wondering if you're thinking about the number 9 in the same way. Do you realize that it's just true, right? It's just true that the number 9 is 3 squared. Somebody says, how do I know I'm supposed to do that? A little bit of experience and realizing that if you can, you do. You make it lower. That answer is fully expanded. It's been like pulled apart. The numbers are also in lowest terms. They're small. I know this is new territory. Okay, but you can understand it. Let's keep working on it. Let's do a natural log. Quite frankly, just so you realize that it's no different. If you see ln, it doesn't change an iota of what we're going to do here. You're welcome to wait for me, but to guide you a little bit, you have two items. What do you do when you have two items? Each one of them becomes a log. It always works this way. That's honestly the first property and the second property sort of put together, well, with, of course, a subtraction sign. It takes some experience, and once you see a few of these, you say, wait a minute, we can make 27 smaller. We can write it in lower terms. It's just true that it's the same as 3 cubed. It's just true. Am I always going to give you a problem where this can happen? Not always. It's understanding that if a number can be written as an exponent, then we can get it in lower terms. All right, natural log of 2 minus 3, natural log of 3. I had a student last period ask, and sometimes we can benefit from other students, probing a little bit about the ln of 27. Not that you need to do this on a calculator, but just so you understand, the ln of 27 is the same as the ln of 3 to the third, which is the same as the 3 ln of 3. Okay, we don't really need to worry about that decimal except to notice that they're all the same. Okay, that's kind of the cool thing about these log properties. That's why they're properties, because they're always true. Now, expanding something, sometimes people say, why would you want to do that? Like, why do you want to take something complicated? Why do you want to take something simple and make it complicated? Well, there's a place for it, but I'm going to be honest with you, it's more likely that you're going to want to do the opposite, that you're going to want to condense. Condensing is taking something that's complicated and making it simple. Now, condensing is a technical word that we use for logs, but it really requires taking what we just did and doing it backwards. Now here we have 5 log x plus the log of 9. 5 log x plus the log of 9. Some people have no trouble kind of just doing this backwards. Sometimes it's like, whoa, I need to like reprogram my brain, but you're actually doing those properties from right to left. If you look at those properties, you see that when there are a couple logs, you condense them to be one log. And that's kind of my big message, is that you want to force yourself to write one log. How do you force yourself to do that? Well, write log one time. Don't write it 3 times. The other thing that you have to realize is that in order to do this, all coefficients have to swing back up. Again, you actually kind of have to do this as a pre-step. Now, once I do that, it's as simple as saying, okay, whatever's up here, since it's being added, is going to now be multiplied. So seriously, 9 and x to the 5th, they're just going to be multiplied. And that's all there is to it. So we wrote one log, and we squished it back together by multiplying. It's just the first property up there. Two ln 4 plus ln 3 minus ln 8. It's not uncommon to get a little more nervous about a problem like this. It just seems harder, but I'm here to try to help you realize that both of those top 2 properties are trying to tell you the same thing. They're trying to tell you squish it all back together to be one log. Look, one log. Do yourself a favor, write it one time. Now, there's other things that we have to be aware of. It depends on when you are aware. Some people, they notice the subtraction sign and remember the little jingle, subtraction means fraction. So now I can kind of get myself ready for a fraction. Also, we have a coefficient. A coefficient has to come back up. It's just part of the property. I have to have coefficients taken care of first. Now, usually at this point, people are ready to just like fill it all in. Are you seeing 4 squared? 4 squared, oh, that's the same as 16. I'm just going to go ahead and do that step. Obviously 3. Now, notice there's 2 items that ended up in the numerator. That's fine. Okay, because whatever's positive is in the numerator, and then, well, whatever's negative is in the denominator. It's really that simple. You're writing one log, and then you're filling the numbers in, numerator, denominator. Now, I hope that whenever you can simplify, that you simplify. Like, this is 48 over 8, so I guess that's like, 6, right? Just kind of had a little mental lapse there. So 40. So we get the ln of 6. Now, sometimes people are like, am I done? How do I know? Well, you're done. The ln of 6, if you try to do what we did yesterday, you can't figure out that exponent. There's not a special answer to the ln of 6. So you may keep the answer in that form. Try one. I'm not trying to trick you. Like, bless you. This problem is much like what we just did, just trying to build your confidence a little bit. So it's the log of 9 plus the log of 4 minus 2 log 6. Did you write one log of one fraction? Filling in some numbers, a 9 and a 4. Of course, 2 became an exponent, so it's really a 6 squared. I hope that you just change that to 36. Now, did you probe a little further? This is 36 over 6. Well, geez, that's 1. That's actually the log of 1. And maybe I did pull a little bit of a fast one on you here. The log of 1 from yesterday is equal to something. So we're trying to tie a little bit of yesterday into today. Wait a minute, the log of 1, wait, that's an exponent. It's the exponent that you put on 10. So you're kind of, in your brain, you're thinking 10 to what power is 1? If you need to write that off to the side, 10 to what power is 1? Well, kids, what's the power that will always get you 1? What's the power that will always get you 1? It's 0. So this is kind of like a special answer. The reality is all this stuff adds and subtracts to be 0. Okay, now we could do more. I could give you some problems to practice. I'm going to more do that, obviously, with the homework. And then tomorrow, there will be a nice practice paper. Okay, so we